We often hear a simple story. Guglielmo Marconi invented the radio in 1895. It sounds neat, it sounds clean. One person, one great invention. But science, my friends, is rarely that simple. Discoveries are often like stars forming from clouds of shared knowledge. Many minds contribute, many hands build upon what came before. The story of radio is not just Marconi's story, it is a human story, a story of collective curiosity. Imagine a world where Marconi never pursued his specific experiments. Would we still be tethered by wires? Would the air around us remain silent? The truth is, the fundamental principles of electromagnetism were already being uncovered. The stage was set, the actors were many. If one key player had missed their cue, another was likely waiting in the wings. This exploration is not to diminish Marconi's significant achievements, but to place them within a grander, more intricate tapestry of scientific endeavour. James Clerk Maxwell, a Scottish physicist, had already predicted the existence of electromagnetic waves. He showed with elegant mathematics that electricity, magnetism and light were all connected. So when we talk about the invention of radio, we must look beyond a single name. The invention of radio was less a solo sprint and more a collaborative marathon, run by humanity's brightest minds across different nations and different fields of study. Let us journey back to Germany in the 1880s. Here, a brilliant physicist named Heinrich Hertz was hard at work. He was driven by pure scientific curiosity. Hertz wanted to prove Maxwell's theories. He wanted to see these invisible electromagnetic waves. He devised ingenious experiments. He used spark gaps to generate high-frequency electrical oscillations. He created a transmitter and a simple receiver. Hertz successfully generated and detected these waves in his laboratory. He showed they could travel through the air. He demonstrated that they had properties similar to light. They could be reflected, they could be refracted, they could be polarized. He measured their wavelength and speed. This was a profound confirmation of Maxwell's predictions. Hertz had made the invisible visible in a scientific sense. Yet Hertz himself did not foresee the vast practical applications of his discovery. When asked about the uses of his waves, he reportedly said, "It's of no use whatsoever." He saw it as a triumph of fundamental science, not as the key to a global communication network. Hertz's work, however, spread like wildfire through the scientific community. His work was the essential starting gun for the race towards radio. Across the Atlantic, in the United States, another towering figure was exploring the frontiers of electricity. His name was Nikola Tesla. A Serbian-American inventor, engineer, and futurist, Tesla was a visionary. He dreamed of a world powered and connected wirelessly. Tesla's work with high-frequency alternating currents was groundbreaking. He developed the Tesla coil, a resonant transformer circuit capable of producing high-voltage, high-frequency electricity. In 1893, years before Marconi's first successful transmissions, Tesla gave public lectures and demonstrations. He described and showed the principles of wireless communication. He even predicted the transmission of intelligent signals, not just simple sparks. Tesla's vision extended far beyond simple telegraphy. He imagined a global system for broadcasting news, music, and even pictures. Meanwhile, in Russia, another scientist was independently treading a similar path. Alexander Stepanovich Popov was a physicist and electrical engineer. He was keenly interested in Hertz's experiments. Like others, he saw the potential of these newly discovered waves. Popov's initial focus was on a practical problem, detecting distant lightning storms. This might seem unrelated to radio communication at first glance. But think about it, a lightning strike is a massive natural spark. It generates strong electromagnetic waves. Detecting these waves is, in essence, a form of radio reception. In 1895, the same year Marconi began his key experiments, Popov presented his lightning detector. This device used a coherer, an early form of radio wave detector improved by others like Edward Branly and Oliver Lodge. Popov's innovation was to add an automatic tapping mechanism to reset the coherer after it detected a wave. This made it much more practical for continuous operation. He demonstrated his device to the Russian Physical and Chemical Society on May 7, 1895. Section 5. The Unsung Pioneers Lodge's Tuned Precision. Let us now turn our attention to Great Britain. Here, Sir Oliver Lodge, a physicist and writer, was also a leading figure in the exploration of Hertzian waves. Lodge was a meticulous scientist. He was deeply interested in the phenomenon of resonance. He understood that to make wireless communication truly effective, you needed more than just a transmitter and a receiver. You needed a way to tune them. You needed them to be on the same wavelength, so to speak. This would allow for selectivity, preventing interference between different signals. In 1894, a year before Marconi's initial successes, Lodge delivered a famous lecture at the Royal Institution in London. He demonstrated the transmission and reception of electromagnetic waves over a distance. He used an improved version of the coherer, a device whose resistance changed when exposed to radio waves. Crucially, Lodge emphasized the importance of syntony or tuning. He showed how adjusting the electrical properties of the transmitter and receiver circuits could make them more sensitive to specific frequencies. This was a vital step towards practical radio systems that could handle multiple transmissions. Section 6. The Unsung Pioneers, Bose's Millimeter Marvels. Our journey takes us now to Calcutta, India. Here, Acharya Jagadish Chandra Bose was conducting extraordinary experiments. Bose was a polymath, a physicist, biologist, botanist, archaeologist, and writer. In the mid-1890s, his research focused on very short electromagnetic waves. We are talking about millimeter wavelengths, much shorter than those used by Marconi or other contemporaries for long-distance communication. These are the frequencies we now associate with microwaves and modern high-bandwidth applications. Bose was truly ahead of his time. Bose designed and built sophisticated equipment for generating, transmitting, and receiving these high-frequency waves. He developed a new type of coherer using galena crystals, a precursor to the crystal detectors used in early radio sets. He demonstrated his experiments publicly in Calcutta in 1895. Section 7. A world without Marconi, the inevitable broadcast. Imagine an alternate timeline where Marconi did not pursue radio. Would the airwaves have remained silent? No, radio's invention was inevitable. Scientific principles were public. Maxwell laid the foundation. Hertz proved electromagnetic waves. A global community was experimenting. The momentum was unstoppable. Consider Tesla, Popov, Lodge, and Bose. They were part of a broader awakening. If not Marconi, another would have succeeded. The timeline might have shifted. Adoption might have been delayed. Different countries might have pursued different paths. Section 8. Ripples in time, delayed signals, altered histories. What if that delay had occurred? What if radio's practical arrival was pushed back by, say, a decade? The consequences would have rippled through history. Consider maritime safety. In the early 20th century, ships were the lifelines of global trade and travel, but the sea is a perilous place. Accidents were common. Radio offered a revolutionary way for ships in distress to call for help. The most famous example, of course, is the Titanic in 1912. Its radio distress calls, though not perfectly handled, did summon the Carpathia, which rescued over 700 survivors. Without effective, widely adopted ship-to-shore radio, the Titanic disaster could have been even more catastrophic. Perhaps no one would have known its fate until it was long overdue. Many other maritime incidents, less famous but still tragic, relied on radio for rescue. A delay in radio's implementation would have meant more lives lost at sea. The development of international maritime safety regulations, like the Radio Act of 1912 in the US, spurred by the Titanic, would also have been postponed. The silent oceans would have claimed more victims, unaware that help could have been just a wireless signal away. Section 9. The Unfolding Waves, an Unstoppable Current of Discovery. Marconi, an Italian, conducted crucial early work and found financial backing in Britain. This gave the British Marconi Company a significant head start in the radio industry. If Tesla's vision had found more support in the US, the early leadership in wireless technology might have emerged elsewhere. National prestige and economic benefits were at stake. The map of technological leadership could have looked different. Ultimately, fundamental discoveries find their application. The principles of electromagnetism are woven into the fabric of the cosmos. Once understood, the development of technologies to harness them was an unstoppable current.